Hi everyone, and welcome back to the OceanBase YouTube channel. I'm Brandon, and I work on community engagement at OceanBase. Today we're going to dive into the fundamentals of vectors and embeddings. These two concepts are at the heart of modern AI applications, and understanding them is key to grasping how vector databases like OceanBase work. In this video, we'll break down what vectors and embeddings are, how they're created, and why they're so powerful. Let's start with vectors. In simple terms, a vector is a mathematical representation of an object in a multi-dimensional space. Think of it as a list of numbers that represent something in the world around us, like a point on a map, or even an image or a piece of text. For example, if you want to represent a cat in a way that a machine can understand, you could use a vector. The vector could contain values for features like the color of the cat, its size, or the shape of its ears. Each of these features corresponds to a dimension in the vector, and the values are the coordinates in those dimensions. Now, let's talk about embeddings. An embedding is a specific type of vector that represents an object, like a word, sentence, image, or any kind of data in a dense vector format. Unlike simple vectors that might just have a few dimensions, embeddings usually have many more, which allows them to capture richer, more complex relationships between objects. For example, in natural language processing, we can use word embeddings to represent words as vectors. Words with similar meanings like cat and kitten will have vectors that are close to each other in the vector space. This allows the system to understand relationships between words without relying on exact matches. So, how are these vectors and embeddings created? Well, the process often involves training a model on large datasets. In the case of word embeddings, models like Word2Vec learn to create vectors by analyzing the context in which words appear in a large corpus of text. The model adjusts the vectors over time so that words with similar meanings end up with similar vectors. For images or other data types, the process is similar. A neural network might be trained to recognize key features in the data, and then it creates an embedding that captures the important aspects of that data. These embeddings are then stored in vector databases like OceanBase for fast retrieval and comparison. So why are vectors and embeddings so powerful? The key advantage is that they allow us to measure the similarity between objects in a way that traditional methods can't. For example, once we have word embeddings, we can compare words based on their meaning rather than just their appearance. The same concept applies to images, documents, or even user behavior. With vector databases like OceanBase, we can store and query these embeddings efficiently, allowing us to quickly find the most relevant data. Whether it's finding similar documents, recommending products, or identifying objects in images, vectors and embeddings make these tasks much more effective. To sum up, vectors and embeddings are the foundation of modern AI applications. They allow us to represent complex data in a way that machines can understand and process. And with OceanBase vector database capabilities, you can take full advantage of this powerful technology to build faster, smarter applications. That's all for today's video. If you found this helpful, make sure to like, subscribe, and hit the notification bell to stay updated on our latest content. And don't forget to join our OceanBase Discord community. We'd love to have you there. Thanks for watching, and we'll see you next time.